All right, guys, welcome back to another lesson. Today we're going to talk about special functions, okay? And make sure I have my notes here so I can look off of. So, special functions, in other words, we're just talking about piecewise functions and a step function and absolute value. But the main goal today will be piecewise functions, okay? I'm going to break this up into a couple parts so that way it's a little bit easier to watch, okay? So the first thing we're going to look at, if you look at this picture, notice there's not one equation that creates this. There isn't. It's like parts of things, right? This is a line, but notice they didn't continue with it. They chopped it off. They said, I only want this part of it. Here's a parabola, but it's not the full parabola, right? It's just this part of the parabola. And then we have a horizontal line that doesn't go all the way to the left. It starts here and goes infinitely to the right. So that's what we're looking at. We're trying to figure out what equations can give me this, and then how are we going to partition those in a way, okay? So that's what we're going to do. So in the previous lesson, we modeled data using lines of regression. Now today we're going to write and graph piecewise defined functions, and then we're going to write and graph step and absolute value functions, okay? So piecewise defined function is a function that is written using two or more expressions, okay? We're going to do just two expressions today, and then maybe I'll upload some homework help where we look at some three expressions in one function. I should have said that. So here's my first one, and we're going to graph this guy, okay? And we're going to identify domain range, okay? So taking a look, I got two equations here. Ignore the bottom one for right now. Look at the top one. It's x minus 1. We know what that is. That's a line, right? If I graph it, it has a slope of 1 and a y-intercept of negative 1. So I'm looking at some line. And then negative 1, isn't that like y equals negative 1? That's a horizontal line. So I'm going to have a horizontal line somewhere in this picture. So those are the two functions I'm graphing. I'm graphing a normal line and a horizontal line. So it's nice to keep that in your head before you start graphing. Over here are the restrictions. Only graph this line if x is 3 or less than 3. Only graph this horizontal line if your x values are bigger than 3. That's one perspective to look at it. The other perspective is to say, hey, 3 and less than 3, those numbers are allowed to be used in this equation. Numbers that are bigger than 3 are allowed to be used in this equation. Okay, so two ways of looking at it, graphically and algebraically. So how do we graph this guy? Well, here's my approach to it. These are the restrictions. Why not plug me into here and see what it looks like first? That would be our starting point. I'm allowed to plug 3 in. So 3 goes into this. So 3 minus 1 is 2. So I'm going to go over here. 1, 2, 3, 1, 2. I'm going to put a closed dot because, remember inequalities? I'm allowed to, right? 3 is allowed to be involved in this function. So it's going to be a closed dot. Next, I need more points, right? To draw a line, I need at least 2 points. A couple ways of doing this. One, I know the y-intercept of this guy is negative 1. So why don't I put that down? I'll put a point there, okay? Can we plot more points? Yeah, I know what the slope is. The slope's 1. So I could go down 1 over 1, down 1 over 1, down 1 over 1. I can plot infinitely many points. Or just plug numbers in. 0 is part of this group, right? Isn't 0 less than 3? So I can plug 0 in, I can plug 1 in, and I can keep doing that. But you need at least 2 points. So however you get to that is up to you. All right, now, am I drawing the full line? No. I have to draw the line from 3 and less than that for my x values. So, in other words, my line looks like this. I'm going to draw the full thing just to show you for a second. So there's the full line, but I don't want that. Numbers that are bigger than 3 are not part of this function, so I don't want that. I only want this part of Okay? Now, next one. This is a horizontal line. Okay, this is like me saying y equals -1. So we go to -1 to the y-axis. I'm going to draw a horizontal line, but I need to figure out where it starts. Well, I'll tell you. Look at the restriction. If I plug 3 in, I get -1, right? So plug 3 in, I get -1. Open circle because I'm not allowed to include 3 in here. And then if I plug any other number in, if I plug 10 in, because 10's allowed, right? I get -1. If I plug 1,000,000 in, my output's -1. So no matter what, I don't have to worry about plotting other points. Draw my line, and there we go. There's my function. Once again, could this line be drawn this direction? No. It usually is, but this is the restriction, right? It says, no, you're only going to draw that line when x values are bigger than 3. Okay? Make that a little bit more prominent. So let's talk about domain. What x values are allowed to be in here? That's my first thing. Okay. Well, look at the restrictions. This is what's going to help you. The graph sometimes can, depending on if you're good at reading it, but look at this. I'm plugging in 3 and every number less than that, and I'm plugging every number that's bigger than 3. So looking at the whole function, that's important. When you're doing domain, you're looking at everything. Is there a number, an x number, that I'm excluding? No. So my answer would be all real numbers. Does that make sense? Now, range are the y values. Here's where this doesn't help, but the graph does. Right here, my y value is 2. You see how I'm using every y value that's less than 2? That's part of my domain, or that's part of my range. I know this one doesn't include -1, but this function does. And once again, when you're finding domain and range of piecewise, you're looking at everything. I'm not looking at, well, it doesn't work for this guy, but it works for this guy. No. Domain and range, you're looking at the whole picture. So from here, do I have any y values that are bigger than 2? No. So all y values given that y is less than or equal to 2. I'm saying equal to because isn't that part of the function, right? I'm allowed that. And there we go. Not too bad, huh? It's actually kind of goofy looking, isn't it? Okay? Let's do another one. Okay? And actually, you're going to have the PowerPoint slides, but there's a closer view of what that looks like. Okay? All right, let's try another one. And let me get rid of this. Get rid of this. I am desperately trying to keep this. I don't want to have to keep graphing a coordinate plane, so I'm trying to keep that as much as possible, so that way I can just keep drawing on it. Okay, here we go. So, visually, what's this going to look like? Well, the top one is a line. The y-intercept is 1, the slope is 2, so it's going to look like this. -3 means it's a horizontal line going through -3. Okay, so it's just like the previous picture. That's what I know so far. All right, let's start plugging points in. So I'm going to ignore this one. I'm going to look at the top one right now. Easiest step to do, let's plug -1 into here. Now, some people will say, hold up, Mr. McCullough. I'm not allowed to include that number in there. You're right. That just means I'll have an open circle at that point to show that I'm not including it. But I need that. I need that value because that's where my function is starting or ending, depending on where we're at on the graph. So if I plug -1 into here, I get 2 times -1 is -2, plus 1 is -1. So I get -1, -1, open circle. Because I can't include it, there's no equal to sign there. Okay? So like I said, when people say, wait a minute, I'm not allowed to use it. You're right. That's why it's an open circle there. Okay, 2 ways of doing this. We could use the y-intercept. Isn't the y-intercept 1 here? So I could put a point right there and just be done. Or I can use the slope, right? Up 2 over 1, up 2 over 1. I could plot another point there, up 2 over 1. Either way, I already have 2 points here. That's all I need. If I want more of an accurate line, I obviously would plot more points. So here I go. Okay. I'm going in this direction. Why didn't I draw down here, the full thing? Well, look at the restriction. You want to draw the line where the x values are greater than -1. These x values are greater than -1. That's why I drew the line that way. Okay? Now, next one. Horizontal line. If I plug -1 into here, I get -3. Okay, so plug -1, you get -3. That's down here. And I believe that's a closed dot, right? Because I'm allowed to include that in this function. Now, it's a horizontal line. The real question is, do I draw it this way or this way? Because I'm not drawing the full thing. This says less than -1. So that means I'm drawing this guy in this direction, just like that. And I'm done. There's my piecewise. Okay, domain and range. Here we go. End of the day. That's a very bad bracket. But I'm keeping it in the video, darn it. So, what x values are not allowed or what x values are not included? I don't think there's any. Look at the restrictions here. I want numbers bigger than -1 and numbers less than -1. That's infinite, that's infinite. I'm allowed to include -1. So that's all real numbers. Again. It won't always be like that, just depends on the problem. Once again, domain and range, you're looking at everything. You're not just seeing if it works for one or the other, it's everything. Okay, now range. That's where things get a little bit different. Okay, so from here, I'm not allowed to include -1 as a range value. But anything bigger than that, I'm allowed. So let me write that down. So y is greater than -1. Not equal to, right? That's not part of it. Now look at this. These y values are -3, right? So I could put or y is -3. So when I plug x values into this function, my output is going to be either greater than -1 or it's going to be -3. It's one of those two as my output. I'm allowed to put anything I want into this guy, right? I'm just going to make sure I use the right function. Okay? That's it. There's a piecewise. 2 of them. Okay. Oh, and there's the graph, a little bit larger for you to view. Okay, now we're going to do the opposite. Now we're going to write this piecewise function. Okay, so let's do that. And just for my sake, I'm going to keep this graph. Boop, 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 boop. I'm going to use this grid tomorrow. I could redraw it, but I'm being lazy. Okay, so what do we call this guy? They call it function f. You can call it anything you like, but we'll just say function f. While the brackets. All right, let's look at this guy first. Honestly, it doesn't matter. I'm just going to start here. This is a line, right? Lines are written in y equals mx plus b form. So to write that, I need a slope, and I also need a y-intercept. Okay, what would the slope be for this? Well, see how it's positive? It's going in a positive direction, so I know that. Also, I could find the slope by just counting, right? Over 1, up 1, over 1, up 1. So the slope's 1. So 1x. My y-intercept, hey, I can figure that out. If I go down, what, 1, 2, 3, 4. So it goes -4. That's where it crosses the y-axis. Okay, now I got to come up with a restriction. So this happens if your x values are what? Okay, well I can figure this out. My x value right here is 2. Am I including 2 in this function? No. I want all the values that are less than it, though. So x has to be less than negative 2. Okay, now for the last step. This line, which is a horizontal line, okay, this is at 1, right? So this is y equals 1. Boom. Kind of a weird thing, really. I'm allowed to draw that line if my x values are what? Here's the 2 mark. So my x values would have to be what? Equal to or larger than that. So x has to be greater than 2 for that guy. Oh, did I put negative? I'm so sorry. That's not a negative 2. That's a positive 2. That's a positive 2 on the x-axis, not negative. I apologize. If you're screaming at home, I'm so sorry. You know I can't hear you. All right. Let's keep going. Hey, we're doing some good timing here. Okay. Next up, identify the piecewise defined in this function. So it's one of these options. So take a minute, pause the video. I'm going to jump right into it, the answer. So here's what I would do if I was given this on like an ACT or something like that. I'd look at this horizontal line first. Okay, this horizontal line is at 7, right? Y equals 7. So look, 7, 7, 7, 7. Okay, it all got 7s in it. Okay, can't eliminate it that way. It's worth a shot. See how negative 4 seems to be the restricting line? This one's less than negative 4. This one's greater than negative 4. So, negative, positive, nope. Negative, positive, nope. Negative, positive, nope. Negative, negative. I think this is the guy. I think this one's doing it. So, you're 7 if x is greater than or equal to negative 4. 7, close dot, okay? Greater than or equal to negative 4, we're good. Down here at the bottom, 2x plus 10 if x is less than negative 4. It's less than negative 4, it's not included, that's good. And the slope's 2, we could check it out, right? Down 2 over 1, down 2 over 1, yep. So the last option is our guy for us, okay? All right. So, we're getting into step functions. So we're going to stop there just to make the video a little bit smaller this time around. So that's piecewise functions. That's writing them, coming up with domain and range, and graphing them, okay? I will send another video out on step functions and absolute value functions, okay? We'll do a separate video, and then I'll do one final video on evaluating with this, okay? How do we evaluate with piecewise functions, okay? And that's it, guys. So, hope you're doing well, okay? Sorry for the video coming out late this time around. If you have any questions, please let me know. But until next time, I will see you all later.